This is a LiDAR360 version 5 basic tools tutorial. One of the most useful features of LiDAR360 is its ability to interface with data in many file formats. You can import point clouds, tables, images, models, or vectors into LiDAR360. It allows you to visualize, emit, and edit your point cloud as well. LiDAR360 allows you to visualize vast amounts of point cloud data using the best data representations. For your analysis, you can change the coloration of the point cloud displaying by classification or intensity, GPS time, turn number, etc. You can also enhance the render effect using tools such as EDL, PCV, and Glass, which are intuitive and helpful for quality. Check the display by classification tool is used for displaying point cloud data. The classes of point cloud data are mapped to discrete color values so as to distinguish different classes of point cloud data more intuitive. The display by blend was used for displaying point cloud data of elevation attribute and intensity attributes. The point cloud data is mapped to several uniformly varying color intervals so as to reflect the comprehensive variation of elevation and intensity more intuitively and display the feature class and boundary more explicitly. The display by mix tool is used for displaying point cloud data. Different attributes of point cloud data are mapped to several uniformly varying color intervals. At the same time, different ways of attribute filtering are supported so as to display the variation of certain attributes of the filtered point cloud data. More intuitively, the display by file tool is used to display point cloud data by mapping the point cloud data from different files to different color values. Intuitively distinguish point cloud data which are from different point cloud files. The display by EDL tool is used to display the point cloud data and enhance the visual effects of the contour features using the eye-dome lighting mode. EDL is a shading technique that works with other display modes, such as display by height and display by intensity, to improve the depth perception and 3D point cloud visualization. With the glass shader, point cloud objects appear translucent. This effect can be enabled or disabled for individual display window. The glass shader is only applicable to point cloud data. The viewing tools are used to set current active window to some view, set camera to top view, view data from the positive Z to the negative Z direction, view plane and XY plane. Set camera to bottom view, view data from the negative Z to the positive Z direction, view plane and XY plane. Set camera to the left view, view data from the negative X to the positive X direction, view plane and YZ plane. Set camera to the right view, view data from the positive X to the negative X direction, view plane and YZ plane. Set camera to front view. View data from the negative Y to the positive Y direction. View plane and XY plane to front isometric views. Set camera position to the front 45 degrees of XY plane while the back isometric view. Set camera position back 45 degrees of XY plane. Set view mode to either orthographic or perspective. If orthogonal projection is selected, current active window will be set in orthogonal projection. If perspective projection is selected, current active window will be set in perspective projection. The full extent tool is applicable to all data types supported by LiDAR360. It makes all the data cover the entire window and top view and provides full view of all. The cross selection tool cross-selects partial point cloud using ROI. The boundary and the rotation angles of the ROI can be entered into the user interface or interactively changed by using the mouse. This function can be used for flood analysis and other applications. The Configure Point Size and Type tool can be used to configure point size and type. If circular points option is checked, point will be rendered a circle, otherwise point will be rendered a square. This function is global. If users want to configure a single point cloud, just right-click it and select Configure Points Size and type from the menu. Create New Viewer allows the user to create a new window in the current project. The section editing function allows the user to display the point cloud data of any rectangular area in the main window, in the section window, which is convenient for the user to view, measure, and modify the class. The pick point tool is applicable to point cloud data, raster data, and model data. For point cloud data, the attributes that can be queried contain position, intensity, return number, classification, and GPS time. For raster data, the attributes that can be queried contain position, stretched their GB value, and pixel value. Form multi-pick point tool. This tool allows coloring multiple points at the same time, and this selection set can be exported in TXT, CSV, and many other formats. Point density is an important metric to measure the quality of point cloud data. The average number of points per square meter can be counted with the density measurement tool. The length measurement tool is applicable to point cloud data, raster data, and model data, which calculates the distance between two consecutive points. The volume measurement tool is applicable to point cloud data and model data, which calculates filling, cutting, and total amount relative to a reference height. The measurement area can be selected either by interactively selecting polygon vertices or inputting the vector files of the polygon. It's commonly used in volume measurement of coal, pile, and haul. The polygon selection tool selects points in polygon area, and there are a few other options available, such as rectangle and sphere. The InCut tool cuts point clouds. After selection, the selected points are kept while the unselected are hidden. While for the Outcut tool, the selected points are hidden while the unselected are kept. The Save Cut Results tool allows users to save results after cut operation as new point cloud files. Click by Circle tool extracts the point cloud data within user-defined circles, and the extracted points can be saved in one or multiple files. The point clouds can also be clipped by rectangle or polygon shape. Extraction tools include extract by class, extract by elevation, extract by intensity, extract by return, and extract by time. Extract by class tool can extract all the point cloud data of the user selected class and save the data in one file. Extract by elevation tool can extract the point cloud data of the user defined elevation range to a file. Extract by intensity tool can extract all the point cloud data within the user defined intensity range. Extract by return tool can extract all the point cloud data of the user defined return number and save the data in a file. Extract a GPS time tool can extract all the point cloud data within the user defined GPS time range and save them in a file. Except the extract by GPS time tool, all the other extraction tools support multiple file operations. Conversion tools provide the option to convert files between various formats. Convert LAS to LiDATA. It can convert point cloud data in LAS or LAS formats to LiDAR360 customized point cloud format. LiDATA format. Users can select the attributes that need to be exported. All LAS attributes are supported. The units of the importing point cloud file choose from meter, decimeter, centimeters, millimeters, feet, and inches. LiDATA 2.0 supports all the features of LAS 1.4. LiDATA 1.9 is mainly used to support LAS 1.0 to 1.3. When exporting from higher versions to lower versions, the exceeded field range limitation will be set at 0. Convert to LAS can convert point clouds and LiDATA format to LAS format, namely the standard LiDAR point cloud data format. The Convert to ASCII tool can convert the LiDATA to ASCII point cloud in a text format that can be easily viewed in a text editor. LiDAR360 supports two suffix formats, TXT and CSV, and support separators are commas, spaces, and tabs. The Convert to TIFF tool can convert LiDAR point cloud data to raster images according to the attribute of the points and cell value method. The Convert to DXF tool can convert LiDATA format point cloud files to point vector data in DXF format. LiDAR360 software exports DXF files in ASCII format. Convert to a model tool can convert single band raster data, DEM, DSM, CHM, etc. to LiModel format. The LiModel format is a LiDAR360 software customized format that allows the converted single band raster data to be displayed and edited in a 3D window. The Convert TIFF to LiDATA tool is particularly useful when the users can hardly acquire point clouds in a certain area but have accurate raster product. This function can help to simulate the point cloud data in the region missing LiDAR points. Ground points classification is an important operation in point cloud preprocessing, which can be implemented in LiDAR360 with an improved progressive. The triangular irregular network classification filtering algorithm. The algorithm first generates a sparse, triangular, irregular network through seed points, and then iteratively processes layer by layer densification until all ground points have been classified. Because the actual terrain is complex and changeable when using this function, to perform ground point classification, different parameters need to be adjusted in order to achieve relatively ideal results. In addition, the classification result and local area can be reclassified by classified ground by selected, and classified by interactive editing tool. The classified by machine learning tool uses random forest method to classify point cloud data. In the same batch of data, it is necessary to manually edit the categories of a small amount of data. After the model is trained, a large amount of data is processed in batches, and it is used to reduce the amount of labor. This feature supports two kinds of processes. One is through selecting training samples, generating training models, and classifying the data. The other is classifying the data directly using the existing models. Profile editing tool allows users to view the profile of the point cloud data in the selected rectangular area. Users can view, measure, and edit the data in the profile window. If users want to produce the topographic production with high accuracy, it is necessary to manually check and modify classification results, and the profile tool is used for that. Starting from version 3.1, the software offers two methods to modify the result of automatic classification. Split the data into blocks, read the data as a whole, and offers multiple windows to display the data. Profile Editing Panel and LiDAR360 offer several tools to edit the point cloud data. It is suggested to use hotkeys in this function, along with the mouse. Users can switch the tools easily and finish the inspection and editing efficiently. This section will further show you the volume measurement options available and LiDAR 360 in its workflow. If you open this tool, the options of volume measurement methods will pop up. If volume measurement is selected, users need to select the measurement area by clicking the mouse. If measurement area is defined by file, users can load the file with measurement area information to measure the volume of the target object. It is suggested to adjust the window to top view before the tool is used. Cell size defines the smallest unit size for calculation. The smaller the value, the more accurate the calculation is. Basic height defines the reference plane to calculate the filling and cutting data source. Specify the points used to calculate the volume. This tool only works with point cloud data and model data in 3D view. Define projection information for point cloud data, including geographic coordinates and projection coordinates. Note that when you use this tool projection information for point cloud data, they should not have projection information. Previously, users can add external coordinate system settings or customize coordinate system settings, such as geographic coordinate system or projected coordinate system. The point cloud can be projected among geographic coordinate systems and projected coordinate systems when different geographic coordinate systems are converted to each other. LiDAR360 provides the 7-parameter transformation model to adjust the differences between ellipsoids and reference planes. To achieve this, users can select the Using the 7 parameters option, push the 7 parameter setting button, and then enter the values for X translation, Y translation, Z translation, X-axis rotation, Y-axis rotation, and Z-axis rotation, and scale factor for the 7-parameter transformation. By entering the coordinate system keywords, the corresponding coordinate system can be filtered from the coordinate reference systems of the world. For example, to set the point cloud coordinate system to WGS 84 UTM Zone 26S, users can enter UTM 26S in the filter for fast screening or enter its EPSG number 32726 for quick search. Users can also import external coordinate systems by clicking the Add Coordinate System button. Control Point Report tool will create a report about elevation differences of LiDAR point clouds and ground control points, which can be used to check the elevation accuracy of LiDAR point clouds and improve the height accuracy of LiDAR point clouds using calculated adjusted values. Control point file is a text file separated by comma. Every row is composed of 3 columns, which are X, Y, and Z. At least 3 control points are requested to successfully create the control point report. The output report displays information of elevation difference between these LiDAR point clouds and control points of elevation, statistic information of height difference like average magnitude, standard deviation, root mean square, average of elevation differences. While the elevation of raw laser data is normally represented by ellipsoidal height, normally these values need to be transformed to values in regional height system or local height system. For large area, the adjustment of elevation cannot be defined as a mathematical formula. Hence, the model of elevation adjustment is required to be defined. The algorithm is used to build triangular network model using known controlled point data, as well as to interpolate and correct local points using height anomaly between different height systems. Adjusted elevation results can be checked accordingly to the control point report. LiDAR360 software supports multiple coordinate transformation methods. Users can select a transformation method to perform coordinate conversions according to their need. The 4 supported coordinate transformation methods are linear, XY multiply, translate and rotate, and 3D affine. For more information on each of these methods, please refer to the user manual. Thank you.